Welcome to this grounding system video of the electrical safety series. The earthing system, in combination with protective devices such as circuit breakers and residual current circuit breakers, ensure the safety of the user of an electrical installation. A grounding system, also known as earthing system, creates a safe route for the current to flow into the ground if the phase or neutral wire touches the casing of electrical equipment. If there is not a proper grounding system in place, you would get an electric shock if the phase or neutral wire inside the appliance, such as the fridge, came loose and touched the metal casing. However, if the earth terminal is connected to the metal casing, the current goes through the earth wire instead of causing an electric shock to the user. We will start with some basic concepts about grounding systems. A grounding system is a complex and delicate part of an electrical installation. A grounding system not properly installed can be very dangerous. There are different ways of installing it, but in this video, as in MSF, we focus on the TT system. Check the electrical safety guideline for further information. In case of doubt, contact your LOGCO or your HQ technical referent for advice. A grounding system consists basically of a grounding copper rod, the green and yellow grounding cable in each circuit of the installation, and the grounding pin of the sockets and plugs. All structures must always have a grounding system for the masses. In case there is a generator, it should also have its own grounding for the neutral. These two groundings should always be independent and not connected between them, and installed at least 20 meters away from each other. Transformers also have grounding for the neutral, which is installed by the electrical company, never us. Let us see how to install a grounding system. A grounding rod is buried in the soil. The electrical resistance of the soil is very important. It should be as low as possible to make easier the current flow into the ground. The most suitable grounds are clay. We should try to avoid sand and never use water ponds or rivers. Sometimes there is a small layer of sand which can be easily avoided by digging. The grounding rod should be made out of copper, if possible, and be around 2 meters long. This rod is connected to the structure through a 25mm square cable. This cable is connected to a cutting bar and then to the electrical distribution board. This cutting bar allows us to disconnect the grounding rod for inspection or making grounding tests safely. Inside the distribution board, the cable coming from the cutting bar is connected through the grounding bar to all the grounding wires of the different secondary circuits. In each secondary circuit, the grounding wire should reach the sockets and lights along with the phase and neutral. The grounding cable should always be yellow and green. The size of the grounding wire in the secondary circuits should be at least the same size of the neutral and phase cables. We should make sure the grounding cable reaches all electrical equipment. To ensure this, all sockets must have 2 poles plus grounding, as we can see in these examples. The plugs and sockets of the installation should be of the same kind. UK plugs for UK sockets, French plugs for French sockets, and so on. Otherwise the appliances won't be grounded. So remember, in order to have a proper grounding system, check if your installation has proper grounding system in place. If it does not have, build it. Make sure the grounding cables reach all electrical sockets and lights. Having a proper grounding system in place does not exclude you on encompassing the rest of the safety measures, RCCB and CB. Don't forget to consult the electrical safety guideline for more information about the subject. It is a complex matter. In case of doubt, contact your technical referent for advice. Thank you for listening and see you in the next electrical safety video.